Now the phasor becomes useful. For any circuit element, we want one compact rule between the voltage phasor and the current phasor. In sinusoidal steady state, that rule is written as V equals Z times I. The multiplier Z is called impedance. It keeps magnitude and phase inside the same object. Start with the resistor. In the time domain, V equals Ri. Nothing differentiates or integrates here. So, the phasor form stays simple. V equals Ri. The impedance of a resistor is just R. It is purely real. And voltage and current are in phase. Their phasors point in the same direction. Now the inductor. In the time domain, V equals L di over dt. A derivative in sinusoidal steady state contributes a factor of j omega. So the phasor equation becomes V equals j omega Li. That means the impedance of an inductor is Z sub L equals j omega L. The j places it on the positive imaginary axis, and voltage leads current by 90 degrees. As frequency rises, the inductive magnitude grows. For the capacitor, the time domain law starts as I equals C dV over dt. So, in phasor form, I equals j omega CV. Rearranging gives V equals 1 over j omega C times I. So the impedance is Z sub C equals 1 over j omega C or negative j over omega C. Capacitive impedance lies on the negative imaginary axis and current leads voltage by 90 degrees. As frequency rises, its magnitude gets smaller. Now compare the three. Resistance sits on the real axis. Inductive reactance points upward on the imaginary axis. Capacitive reactance points downward. The resistor dissipates power, while the inductor and capacitor mainly store and return energy. Frequency does not move R, but it pushes the magnitude of Z sub L up and pulls the magnitude of Z sub C down. Take a quick numeric check at omega equals 1000 radians per second. If L equals 10 millihenries, then Z sub L equals J10 ohms. If C equals 100 microfarads, then Z sub C equals negative J10 ohms. Same magnitude, opposite imaginary direction. That sign difference is exactly why inductors and capacitors affect phase in opposite ways. Impedance is the phasor domain multiplier between voltage and current. For R, it is real. For L, it is positive imaginary. And for C, it is negative imaginary. In the next lesson, we will place these impedances inside A, C, K, V, L node and mesh equations.